Welcome to the Crazy Hat Chemist. So here we go. Stoichiometry and dimensional analysis unit. Today we're doing the 9th part here, and we're going to do a percent yield calculation. So here we go. Bam! So 0.296 grams of aluminum metal reacts with hydrochloric acid. What mass in grams of gas is produced? If only 0.0158 grams of gas was collected, what is the percent yield? So there's a lot in this problem, so make sure that this is a total stoichiometry problem and then a percent yield here at the end. So hydrochloric acid, that is a binary nonmetal acid. You're going to take the 1 plus charge and the 1 minus charge, flip them, bring them down, you get an HCl. That's aqueous. And then aluminum is a metal. And that's why you get the following. And that's a solid for the aluminum and hydrochloric acid. If you're confused about the hydrochloric acid on this one and on the previous problem, that's 8.5 video, then you really need to review your nomenclature of acids. What type of reaction is this? This is a single displacement reaction. So that means that the aluminum is going to displace the hydrogen. And then the hydrogen is going to be an element by itself, and then the aluminum and the chloride are going to get together. You're going to include the states of matter on the product side, and then you're going to balance it. So I want you to pause the video here, and then write the balanced chemical equation with the correct stoichiometric coefficients that we're going to use to convert from the aluminum metal to the grams of gas. Here we go. Unpaused. So here's our balanced chemical equation. That is, the aluminum is going to displace the hydrogen, and hydrogen by itself is one of these diatomics. That's flip it, bring it down. You got 7 of them on the periodic table, and they are diatomic. That means there's 2 of them. The aluminum is a 3 plus charge. That's a periodic trend. The chloride is a halogen, and that's a 1 minus charge. And that's a 3 plus and a 1 minus. I'm going to flip those numbers and bring them down, and I get AlCl3. And then you need to balance it, okay? And you're going to look at those videos on chemical reactions so that you can know how to balance it, okay? I'm starting off with aluminum, and then I'm going to end up with hydrogen gas. That's the only gas, okay? So I'm going to go from the aluminum to the hydrogen gas. I'm looking at this flow chart here. Now, we have been using this flow chart so many times, I hope you are familiar with it. So I will try to step you through it here verbally. You're going to write it out instead, because this is going to vanish here really soon, because we're going to need all this space for this problem. So I got grams of aluminum, so therefore we're starting off with a mass. Then I'm going to go from grams of aluminum to moles of aluminum using the molar mass that's on the periodic table. Then I'm going to go from moles of aluminum to moles of hydrogen using the stoichiometric coefficients that you see there. That is 2 moles of aluminum, 3 moles of hydrogen gas. Then I'm going to go from moles of hydrogen gas, that's 1 mole of hydrogen gas, to the grams of hydrogen gas, and that is a diatomic. So I want you to pause the video, write out that whole entire monorail of stoichiometry, make sure you have number, units, formula, cancel out your units and formula, look at your significant figures on all of your problems, on all of your steps of your problem. Then I want you to get a calculator answer, write that calculator answer down, look at the significant figures that you have, and then you're going to unpause it. So pause it right now, and then unpause. So this is our stoichiometry here. We are using this mole ratio of 3:2 for hydrogen to aluminum. It's actually aluminum to hydrogen. We are canceling out the grams of aluminum and canceling out the moles of aluminum and canceling out the moles of hydrogen. And now we're left with grams of hydrogen. Okay, we're going to look at the significant figures that we have. There's 3, infinite, infinite, and wow, 5, and infinite, and infinite. Remember, leading zeros do not count, trailing zeros count, and captive zeros count. So the least number of significant figures on this problem is 3. And here is my calculator answer. So I am looking at that 7 for rounding. That 7 is 5 or greater. So I'm going to add 1 to the preceding digit. That 1 becomes now a 2. So right here, 3.32 times 10 to the negative 2 grams of hydrogen is actually one of my answers. That is, the answer is what mass in grams of hydrogen gas is produced. That's my answer. Now what I have to do is I got to get the percent yield of the problem. So any percent problem, whether it's your grade or whatever it is, how many the percent of free throws that you have or the percent of goals that you kick, is always the part divided by the total times 100. That 100 is an infinite number of significant figures, and that will give us a percentage. That is a generic percentage formula. So what we're going to do on these problems is we have a more precise formula here. That is, the percent yield is the actual divided by the theoretical times 100. The other way to state this is that the actual is a given value. The theoretical is always calculated. So the actual is given in the problem somewhere. The theoretical must always be calculated. So I got to figure out from all the numbers that I have here on this slide, which one's the actual and which one's the theoretical. This one right here is a calculated value, so therefore it's theoretical. That's the amount of hydrogen gas that you could potentially produce under the most optimal conditions. And then this value right here is the given value of hydrogen gas that is actually collected, and that's given. So I'm going to plug those into my actual and theoretical, and you should see that you have three significant figures for both the numerator and the denominator. The 100 is an infinite number of significant figures again. The leading zeros on the 0.0158 and the 0.0332, those leading zeros do not count. So here we go with our answer of three significant figures, and that is 47.6% hydrogen. I still have a number, units, and a formula for that problem. And I hope that problem worked well for you. I've got a football on my head. Bam!